Hey guys, today we get to start taking a look at forces, and we cannot take a look at forces without taking a look at a couple of Newton's laws and energy transfer. So that's what we're going to be taking a look at today, okay? So please get out your science notebooks and a pencil, and you're going to label this forces. Label this forces. Today's date is October 14th. So get out your notebooks and go ahead and start taking some notes, okay? All right, so we are going to take a look at Newton's first law, the law of inertia. And you might be saying, well, Mrs. Wire, I don't even know what the term inertia means. Okay, and you did look at a little bit of this in your reading for warm-up, but let's define a couple of terms. Okay, so I want you to go ahead and write this down as I write this down. All right. So inertia is the tendency to do nothing or to remain unchanged. That's what inertia is. Okay. So inertia is the tendency to do nothing or to remain unchanged. So Newton's first law, and you guys are probably familiar with this, is that objects at rest are going to stay at rest because inertia is the tendency to do nothing or to remain unchanged. So if I have something that's velocity is 0, it's not accelerating, it's not moving, it's going to stay not moving. Okay, so Newton's first law is objects at rest will stay at rest. Okay. Also, it tells us that objects in motion will stay in motion because if something is moving and there's no acceleration, the velocity is not equal to 0, that means it's moving somehow, okay, then it's going to stay in the same speed and the same direction. It's going to keep moving how it's been moving. Now we know that this isn't true on Earth, right? Eventually things are going to stop, so eventually we'll have to talk about forces that stop this law, but that's Newton's first law. Okay, so Newton's first law, we can write this down too. Newton's first law tells us objects at rest will stay at rest, and objects in motion will stay in motion. Okay, so go ahead and write that down. And you can ask the sub kindly to pause that for you, okay, if you need more time. All right, but like I said, we know that that's not totally true. We know that an object doesn't always stay at rest, an object doesn't always stay in motion. Well, why not? Because objects are acted on by another force. Hopefully it's not like a train, like this one, okay? But objects are and can be acted on by another force. So that brings us to Newton's second law, okay? Newton's second law. And that tells us that the mass of a body, and I want you guys to write this all down, Newton's second law tells us that the mass of a body determines the momentum of the body at that given velocity. Okay, the mass of a body determines the momentum of the body at a given velocity. You might be asking, well, what's momentum? Can you define momentum for us? So you bet I can. All right. So, and I'll come back to that. And and you can always pause this, ask to be paused. Momentum is motion of a moving body, and it is measured by mass and velocity. So basically what this is telling us is momentum is related to mass, so how much of something there is, how the speed that it's going. Okay, so what is its motion? And its motion is being measured by how much there is and how fast it's going. That's what momentum is. Okay, so Newton's first law tells us that the mass of a body determines the momentum of the body. I just put it a little bit of a different way. Okay, so P stands for momentum. So when you write this down, this formula right here, I want you to draw a little arrow so you remember P is for momentum, M is for mass, V is for velocity. Okay, so P is momentum, M is mass, V is velocity. This would be a good spot to pause and make sure that you're getting that written down. And I want you to take a look at the units that we have here. So we know that mass is going to be measured in grams or kilograms. Typically when something is moving, it is large enough that we're going to be measuring it in kilograms. Okay, so we're switching to kilograms now, not just a gram. So mass is measured in kilograms. Velocity, we know, is measured in meters per second. Okay. And a kilogram times meter per second, that's a joule. Okay, because this is a hard unit to describe, kilograms times meter per second. So we just call that a joule. All right, and we'll come back to this and I will continue to remind you of what that is. Okay, but you might want to define it like this. So you have it down in your notes really well. So a joule is the SI unit of work or energy, okay? And energy, remember, is the ability to do work. And it is the work done by a force of 1 Newton moving 1 meter in the direction of the force. Okay. And you guys defined a Newton when you were doing your warm-up this morning, but let's just define that as well. So a Newton is the SI unit for force, and it causes 1 kilogram to accelerate, so that much mass to accelerate at a rate of 1 meter per second squared. Okay. So again, it can be referred to as a kilogram times meter per second squared. Okay. So if we go back here, the joule has to do with a velocity. A Newton, because we know that it's meters per second, kilogram meters per second, so we can add that over here. Okay, kilogram times meters per second. And then the Newton has to do with acceleration because it's a kilogram per meters per second squared. makes sense to me to write it down like this, go ahead and pause it and make sure that you have this information here, okay? All right. So mass, as related to inertia of a body, can be defined by the formula force is equal to mass times acceleration, okay? So so here we have just momentum, mass, and velocity. But here we're going to relate that to movement. Okay, so we're going from not moving to moving, which means acceleration, because inertia is something that's sitting still, right? Or not wanting to change. But we know that things do change. So mass, when we relate it to inertia, we're going from not moving to moving. Now it's acceleration. Okay, so force, when a force is acting on something else, we're going to use force equals mass times acceleration. Okay, and I just described this over here, the Newton. So force is equal to mass, which is measured in a kilogram, right? Acceleration is measured in meters per second squared. And so then we measure that in kilograms times meters per second squared, and we define that as a Newton. Again, we use that because this is too much to say. All right? So remember, F is for force, M is for mass, A is for acceleration. It might seem like a lot now, but we will continue to use these formulas again and again because perfect practice makes perfect, and we'll get them to stick, okay? So for right now, what you need to remember that a joule is for momentum, okay? So how fast something is going, just velocity. Okay, a Newton is work being done. It's acceleration. It has to do with something changing speed. Okay, so that's the difference between a joule and a Newton. I'm going to pause this here because we're running out of time on my video, and then we will do an example. Okay.